So now we begin looking at the structured query language, which is the primary language that we use for interacting with relational databases. And for this section, we're going to talk about a particular part of the structured query language that allows us to create and alter a relational database. So why should we learn SQL? Well, it's the standard for creating and querying relational databases, and it's very, very common. It's in common use across all of the relational database management systems that are out there right now. So by learning SQL, it reduces vendor dependence and it reduces corporate training costs, because if you know SQL, then you can apply it across all types of database management systems. And you'll hear me use interchangeably probably SQL and SQL. So some people refer to this as SQL. So if you hear me say that, I'm talking about the structured query language. There are three types of languages that are part of SQL, and the first is a data definition language, and that's what we're going to be talking about in this particular video. It defines the database schema for creating, altering, and dropping tables and constraints. Usually database developers use the data definition language itself. Data manipulation language is the one that most database users would use, where you're querying and maintaining a database by selecting, inserting, updating, and deleting data. And then you have the data control language, which is most often used by database administrators because it controls database security and access, administering privileges, committing transactions, and things of that nature. So what we're focused on in this particular video is the data definition language. But first, let's look at some general SQL rules. The statements themselves are not case sensitive. You can use uppercase, you can use lowercase, and it does not matter. Table names, however, may be case sensitive depending on the platform. So you should understand the platform that you're using and follow that convention. Statements within quotation marks, either single or double quotation marks, or even the tick mark, those would be case sensitive, so you need to remember that. If you use quotation marks, any type of quotation marks around your table names or column names, then it would become case sensitive. SQL statements can span multiple lines. It doesn't have to be on a single line, so it allows you to expand the statement so that you can better organize it and better review what is going on in a particular statement, because some SQL statements get very, very long and it needs to be well organized. The thing that typically signifies the end of an SQL statement is a semicolon, and the use of the semicolon is most often there. It doesn't always have to be there, but if you have multiple statements within a file, then you should always end your SQL statement with a semicolon. Otherwise, you could end up running into errors. We're going to use MySQL in this course, and there are several data types that we should know about, and these are the most common data types. There are others that I can provide for you, but these are the most common data types. Varchar is a variable length character string, and it has a maximum of size characters. So we see that the size is listed here. The minimum size is 1 and the maximum size is 255. You can also use text for large text values. If you need a value that is above 255 characters, you would change that data type from varchar to text. A numeric value is called decimal. So a decimal is a floating point number with a precision of p and a scale of s. Both of these are optional, P is the total number of digits. So if you say P of 10, then that means it has 10 total digits, including what is after the decimal point. S is the number of digits after the decimal point. So if you say 10 comma 5, then there would be 5 digits before the decimal point and 5 digits after the decimal point. Other available numeric values are float and double for more specificity. You can also use int. If you do not have a floating point number and you just want an integer, you can simply define that as int. Date is a date that allows you to store dates from 1000, January 1st, to December 31st, 9999. So the default format for dates in MySQL is year, 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 year. So 2024, month is 01, and DD is 01. So the day of the month comes at the end. If you also want to include a time with that, the data type that you should use is date time. And date time also includes the time component as part of that. Do not use a timestamp because a timestamp field is an automatic field. And a date time is a non-automatic field that allows you to store a particular date with a particular time. So let's look now at the create statement. The create statement is a command in the data definition language part of SQL that creates the structure of a table in the database itself. So here we are creating a table called employee. We open the parentheses and type employee ID, varchar 9. So that means this employee ID has a maximum of 9 characters. The last name is a maximum of 35 characters. First name is a maximum of 20 characters. And notice each of these is separated by a comma. The birth date is a date because we don't have to worry about the time there. Gender is just a character, so it has 2 possible places. The salary is a decimal with 8 in the precision and 2 is the scale, so that means it can have 6 digits before the decimals and 2 digits after. And the job ID is a character that has 9, at most 9 positions. But where's the primary key? We haven't defined the primary key in this case. So let's do that. What would the primary key be? Well, typically we would say that the employee ID is the primary key of the table. So if we add that, we can just add another column at the end, or another statement at the end of the column list that describes the primary key as employee ID. So we can simply say at the end what our primary key is. Primary key, and then in parentheses, the list of columns that constitutes the primary key. In this case, it's only one column, but sometimes it might be multiple. The other thing we need to be sure of is that we add not null to the actual field to ensure that there is entity integrity. So you notice here at the end of employee ID, we just describe it as being not null, and that ensures the entity integrity that we spoke about before. And also the other thing to note is that when you describe the primary key at the end of the column list, then you always add this comma to the end of the list. So here's another example of a foreign key. Now we have this employee table and we have supervisor ID instead, and a supervisor ID is someone that supervises an employee. So this is called a unary relationship because it is a relationship with itself. The primary key is employee ID, and then we have another comma, foreign key, supervisor ID. So this is the foreign key's name, supervisor ID, and it references the primary key of the employee table. So employee ID. So that identifies a foreign key relationship with itself. And the same is true if it's a foreign key relationship with another table. So if we have a foreign key supervisor ID that references a supervisor table, then we would simply say supervisor's supervisor ID, or whatever field name it might be called. Again, if you have multiple constraints, then add a comma between the multiple constraints within your SQL statements. We have an alter command. The alter command allows you to add columns and constraints, change columns and constraints, and drop columns and constraints. But remember that modifying a column that has data in it already may result in a loss of data. We will look more at alter at another time, but just be aware that that exists. And one of the reasons that we're not going to spend much time on it is because a lot of the tools that you will use allow you to do alters within the database system or the database management tool that you have without worrying about it. Like, for example, we're using the MySQL community software that has a way of altering a table right within the software itself. There are times that you need to drop a table, and drop table is the command that allows you to remove a table from the database. If exists is an option that allows you to say no error occurs for non-existent tables. So in other words, if it doesn't exist, it ignores it. But if it does exist, it drops it. There are also options to restrict or cascade. These don't really do anything in MySQL, but they are there because other database management systems like Oracle use these tools in their drop statements. But our drops will typically be drop table if exists and then the list of table names that you want to drop.